Hello, my dear students. Good evening. Welcome to the class. Myself, Bhagyashree Joshi from Sankalp Learning Solutions. Yes, dear students, today we are going to learn the chapter that is light reflection and refraction. Okay, so this is also very, very important chapter. Already we have studied what do you mean by light and what do you mean by reflection and also what do you mean by refraction. Okay, yes. Now tell me, what do you mean by light? So our chapter name is light, reflection and refraction, right? So what do you mean by light? Yes, so light is a form of energy. Light is also a form of energy because, wait for a minute. Yes. So what do you mean by light? Light is a form of energy like heat energy, wave energy, water energy, electric energy. Like that, light is also a form of energy which helps us to see the object, right? So light helps us to see the object. In the absence of light, we can't see anything, right? How you can see the object? So in the presence of light, how can you see the object? See, when light falls on a certain object, for example, here one object is there. Okay, here one object is there. So here one sun is there. So when light falls on this object and you are standing here, okay, so you are standing here. When light falls on the object, it reflects. Yes or no? It reflects. When reflected ray or reflected light, it reaches our eyes. So light is coming in this direction and reflected light, and it reflects in this direction, and this reflected ray reaches our eyes. In that reaches our eyes, that then we can see the object, right? So when a light falls on the sources of light, when a light falls on the object, then reflected ray reaches our eyes, then only we can see the object. So this is about the light. And what we are going to discuss or what we are going to learn in this chapter is so very, very important. What do you mean by light? So phenomenon of lights that we learned in the last year only. That is reflection, refraction, interference, total interference, then total internal reflection, right? And diffraction. So these all are the phenomenons of light. So in this chapter, mainly we are going to discuss about the reflection and reflection. Reflection and refraction. So what do you mean by reflection and what do you mean by refraction? So reflection, when light falls on a certain object, it bounces back. That we call it as a reflection. Okay. And reflection in case of mirror and spherical mirror. Reflection in mirror and spherical mirror. Then what do you mean by refraction? Refraction means what? Bending of lights. When a light travels from one medium to other medium, it bends. Yes or no? So consider this is a water. Okay. And see, you are placing one pencil here and it bends. Right. So now light traveling from air to water, that is rarer medium to denser medium. Air is a rarer medium and water is a denser medium, right? So a rarer medium to denser medium, when you draw a normal here, it bends towards the normal. Okay, when a light travels from rarer to denser medium, it bends towards the normal. When a light travels from denser to rarer medium, then it bends away from the normal. So this is about the refraction. Refraction means what? Bending a light in different medium. Okay. So ಒಂದು medium ಅಲ್ಲಿ light one ಥರ bend ಆಗತ್ತೆ. Next ಮತ್ತೊಂದು medium ಹೋಗ್ತಾರೆ. See, from air to water. ಅಲ್ಲಿ ಸ್ವಲ್ಪ ಬೆಂಡ್ ಆಗುತ್ತೆ, ಮತ್ತೆ ಫ್ರಮ್ ವಾಟರ್ ಟು ಏರ್ ಬಂದಾಗ ಮತ್ತೆ ಬೆಂಡ್ ಆಗುತ್ತೆ. ಸೊ ಬೆಂಡಿಂಗ್ ಆಫ್ ಲೈಟ್ ಇನ್ ಡಿಫರೆಂಟ್ ಮೀಡಿಯಂ, ದಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ರಿಫ್ರಾಕ್ಷನ್. ಓಕೆ, ಅಂಡ್ ರಿಫ್ಲೆಕ್ಷನ್ ಇನ್ ಮಿರರ್ ಅಂಡ್ ಸ್ಪೆರಿಕಲ್ ಮಿರರ್. ವಾಟ್ ಡು ಯು ಮೀನ್ ಬೈ ಸ್ಪೆರಿಕಲ್ ಮಿರರ್? ಸೊ ಸ್ಪೆರಿಕಲ್ ಮಿರರ್ ಅಂತಂದ್ರೆ ಏನು? ಸೊ ವೆನ್ ಯು ಕನ್ಸಿಡರ್ ಅ ಸ್ಪಿಯರ್, ಓಕೆ, ಒಂದು ಸ್ಪಿಯರ್ ಇದೆ. ಸೊ ಇದನ್ನ ನಾನು ಕಟ್ ಮಾಡ್ತೀನಿ. ವೆನ್ ಯು ಕಟ್ ದಿಸ್ ಸ್ಪಿಯರ್ ಇಂಟು ಟೂ ಪಾರ್ಟ್ಸ್, ಟು ಈಕ್ವಲ್ ಪಾರ್ಟ್ಸ್, ಅವಾಗ ಏನ್ ಸಿಗತ್ತೆ? ಯು ವಿಲ್ ಗೆಟ್ ಟೂ ಪಾರ್ಟ್ಸ್. ಒನ್ ಪಾರ್ಟ್ ಈಸ್ ಲೈಕ್ ದಿಸ್ ಅಂಡ್ ಅನದರ್ ಪಾರ್ಟ್ ಈಸ್ ಲೈಕ್ ದಿಸ್, right? So one part is like this and another part is like this. If this part is meant for the reflection, if this part is meant for the reflection and other part is coated, ಒಂದು ಪಾರ್ಟ್ ಅನ್ನ ನಾವು ರಿಫ್ಲೆಕ್ಷನ್ ಗೋಸ್ಕರ ಇಟ್ಟಿದ್ರೆ, ಸೊ ಒನ್ ಪಾರ್ಟ್ ಏನಾದ್ರೂ ರಿಫ್ಲೆಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ ಆಗಿದ್ರೆ ಅನದರ್ ಪಾರ್ಟ್ ಅನ್ನ ನೀವು ಕೋಟ್ ಮಾಡಿರ್ತೀರಾ. ಕೋಟ್ ಮೀನ್ಸ್ ಪೇಂಟ್ ಮಾಡಿರ್ತೀರಾ, ಅದನ್ನ ಡಾರ್ಕ್ ಮಾಡಿರ್ತೀವಿ. ಓಕೆ, so next here, so in this case this part is meant for reflection and this part is coated, right? ಇಲ್ಲಿ ಏನಾಗಿದೆ, ಈ ಒಂದು ಪಾರ್ಟ್ ಇದು ರಿಫ್ಲೆಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ ಆಗಿ ವರ್ಕ್ ಮಾಡುತ್ತೆ ಅಂಡ್ ಇದು ಈ ಪಾರ್ಟ್ ಅನ್ನ ನಾವು ಕೋಟ್ ಮಾಡಿರ್ತೀವಿ. ಸೊ ವಾಟ್ ಈಸ್ ದ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ದೀಸ್ ಟೂ ಪಾರ್ಟ್ಸ್? see here, reflecting surface is inward, right? Reflecting surface is inward and reflecting surface is outward, right? So ಇಲ್ಲಿ ರಿಫ್ಲೆಕ್ಟಿಂಗ್ ಸರ್ಫೇಸ್ ಎಲ್ಲಿದೆ? ಔಟ್ವರ್ಡ್ ಆಗಿದೆ. ಸೊ ಈ ತರ ಇದೆ. ಸೊ ಈ ತರ ಮಾಡಿದ್ರೆ ಇದು ನಿಮ್ಗೆ ಔಟ್ವರ್ಡ್ ಸರ್ಫೇಸ್ ಆಗತ್ತೆ. ಸೊ ಈ ತರ ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆ ಇದು ಒಂಥರ ಹಿಂಗ ತಗ್ಗಾಗಿರುವ ಭಾಗ ಆಗತ್ತೆ. ಎಸ್, ಸೊ ದಿಸ್ ಇನ್ವರ್ಡ್ ಪಾರ್ಟ್, ದಿಸ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ ಕಾನ್ಕೇವ್ ಮಿರರ್, right? If reflecting surface is inward, then it is called as concave mirror. Okay, then if the reflecting surface is outward, then it is called as convex mirror. Yes or no? Convex mirror. Then another one mirror is there, that is plane mirror. Okay, so ಎಷ್ಟು ಮಿರರ್ಸ್ ನಮಗೆ ಸಿಗತ್ತೆ? there are three types of mirror. One is plane mirror, next one is concave mirror, okay, next one is convex mirror. So there are three types of mirrors. Convex mirror, convex mirror. Plane mirror means what? ಸೊ ನಾವು ಡೇ ಟು ಡೇ ಲೈಫ್ ಅಲ್ಲಿ ದಿನಾಲು ಯೂಸ್ ಮಾಡ್ತೀವಿ, ಹೌದಾ? ಪ್ಲೇನ್ ಮಿರರ್, ವಾಟ್ ಇಸ್ ದ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಪ್ಲೇನ್ ಮಿರರ್, ಕಾನ್ಕೇವ್ ಮಿರರ್ ಅಂಡ್ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್? ಸೊ ನಮ್ಗಿಲ್ಲಿ ಎಲ್ಲಾ ಕಡೆ ಇಮೇಜಸ್ ಬೇರೆ ಬೇರೆ ರೀತಿಯಾಗಿ ಸಿಗತ್ತೆ. ಸೊ ಇನ್ ಪ್ಲೇನ್ ಮಿರರ್ ನೀವು ಹೇಗಿದ್ದೀರಾ ಅದೇ ಇಮೇಜ್ ಅನ್ನ, ಸೊ ಸೇಮ್ ಇಮೇಜ್ ಯು ವಿಲ್ ಗೆಟ್ ಇನ್ ದ ಪ್ಲೇನ್ ಮಿರರ್. ನೀವೇನಾದ್ರೂ ಗಿಡ್ಡವಾಗಿದ್ರೆ ಅಥವಾ ಎತ್ತರವಾಗಿದ್ರೆ ಸೇಮ್ ನೀವು ಅಲ್ಲೂ ಕೂಡ ಹೈಟ್ ಆಗಿನೇ ಕಾಣಿಸ್ತೀರಾ, ಅಲ್ಲೇನಾದ್ರೂ ಗಿಡ್ಡವಾಗಿ ಕಾಣಿಸ್ತೀರಾ? ಇಲ್ಲ ಅಲ್ವಾ? ಸೊ ನೀವ್ ಯಾವ ತರ ಇದ್ದೀರಾ, ಸೊ ಆಬ್ಜೆಕ್ಟ್ ಯಾವ ತರ ಇದೆ, ಇಮೇಜ್ ಕೂಡ ಅದೇ ತರಹ ಬರುತ್ತೆ. ಎಲ್ಲಿ? ಇನ್ ಕೇಸ್ ಆಫ್ ಪ್ಲೇನ್ ಮಿರರ್ಸ್. ಎಸ್ ಆರ್ ನೋ? ಸೊ ಇನ್ ಕೇಸ್ ಆಫ್ ಪ್ಲೇನ್ ಮಿರರ್ಸ್ ಆಬ್ಜೆಕ್ಟ್ ಅಂಡ್ ಇಮೇಜಸ್ ಆರ್ ಸೇಮ್. ವೆನ್ ನೀವೇನಾದ್ರೂ ಮೂವ್ ಮಾಡಿದ್ರೆ ಇಮೇಜ್ ಕೂಡ ಮೂವ್ ಆಗತ್ತೆ, ಹೌದಾ? ನೆಕ್ಸ್ಟ್ ಒನ್ ಈಸ್ ಲ್ಯಾಟ್ರಲ್ ಇನ್ವರ್ಷನ್. ಸೊ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಮೇಲೆ ಮಾಡಿದ್ರೆ ರೈಟ್ ಹ್ಯಾಂಡ್ ಎತ್ತಿದಾಗ ಆಗತ್ತೆ, ರೈಟ್ ಹ್ಯಾಂಡ್ ಮೇಲೆ ಮಾಡಿದ್ರೆ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಎತ್ತಿದಾಗ ಆಗತ್ತೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ದಿ ಪ್ಲೇನ್ ಮಿರರ್. ನೆಕ್ಸ್ಟ್ ಒನ್ ಇಸ್ ಕಾನ್ಕೇವ್ ಮಿರರ್ ಅಂಡ್ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್. ಸೊ ನಾವು ಕಾನ್ಕೇವ್ ಮಿರರ್ ಅನ್ನ ಇಮೇಜ್ ಅನ್ನ ದೊಡ್ಡದಾಗಿ ನೋಡೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ಅನ್ನ ನಾವು ದೊಡ್ಡ ಇಮೇಜ್ ಅನ್ನ ಒಂದು ಚಿಕ್ಕ ಪಾರ್ಟ್ ಅಲ್ಲಿ ಎಲ್ಲವೂ ಕವರ್ ಆಗೋ ಹಾಗೆ ನೋಡುವಲ್ಲಿ ನಾವು ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ, ರೈಟ್? ಸೊ ಹಿಯರ್ ಯು ಕ್ಯಾನ್ ಸಿ ಕ್ಲಿಯರ್ಲಿ uses of concave and convex mirror. Concave mirrors are commonly used in torches, searchlight, vehicle headlight and shaving mirror. In dentist use concave mirror. Uses of convex mirror. So where convex mirrors are used? So convex mirrors are used in vehicles, that means rear view mirror. So ನಿಮ್ಮ ವೆಹಿಕಲ್ ಅಲ್ಲಿ ರೇರ್ ವ್ಯೂ ಮಿರರ್ ಇರತ್ತಲ್ಲ, ಅಲ್ಲಿ ನಿಮ್ಗೆ ಹಿಂದೆ ಬರುವಂತಹ ವೆಹಿಕಲ್ ನಿಮ್ಗೆ ಕಾಣಿಸುತ್ತೆ. ದೊಡ್ಡದಾಗಿರುವ ವೆಹಿಕಲ್ ಏನಾದ್ರೂ ಇಷ್ಟು ದೊಡ್ಡದಾಗಿ ಕಾಣಿಸುತ್ತಾ? ಇಲ್ಲ ಅಲ್ವಾ? ಹಿಂದೆ ಒಂದು ಲಾರಿ ಬರ್ತಾ ಇದ್ರೆ ಅದು ಚಿಕ್ಕದಾಗಿ ಕಾಣಿಸುತ್ತೆ, ಬಟ್ ಹಿಂದೆ ನಿಮ್ಗೆ ಲಾರಿ ಬರ್ತಾ ಇದೆ, ಬಸ್ ಬರ್ತಾ ಇದೆ ಅಂತ ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಾಗತ್ತೆ. ಎಸ್ ಆರ್ ನೋ? ಸೊ ದೇರ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್. ಓಕೆ, ಅಂಡ್ ಕಾನ್ಕೇವ್ ಮಿರರ್. ಸೊ ಡೆಂಟಿಸ್ಟ್ ನಿಮ್ಗೆ ಏನ್ ಮಾಡ್ತಾರೆ, ಸಣ್ಣ ಸಣ್ಣ ನಿಮ್ಮ ಹಲ್ಲಿನಲ್ಲಿ ಇರುವಂತಹ ಒಂದು ಪಾರ್ಟ್ ಅನ್ನ ನೋಡ್ಬೇಕಾದ್ರೆ ಅವರಿಗೆ ಅದು ದೊಡ್ಡದಾಗಿ ಕಾಣಿಸ್ಬೇಕು. ಎಸ್ ಅವ್ರನ್ನ ಈಗ ಏಜ್ಡ್ ಪೀಪಲ್ಸ್ ಇರ್ತಾರೆ, ಅವ್ರಿಗೂ ಕೂಡ ಏನಾಗತ್ತೆ, ಅಕ್ಷರಗಳು ದೊಡ್ಡದಾಗಿ ಕಾಣಿಸ್ಬೇಕು, ಅವರು ಅದನ್ನೇ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ಅಲ್ಲಿ ದೇರ್ ವಿ ಆರ್ ಯೂಸಿಂಗ್ ಕಾನ್ಕೇವ್ ಮಿರರ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್. Already we have studied this topic, right? Just I am doing one small revision. Okay, so this is about the mirrors. Then comes lenses. What do you mean by lenses? What is the difference between mirror and lenses? ಸೊ ನಿಮ್ಗೆ ಇಲ್ಲೂ ಕೂಡ ಕಾನ್ಕೇವ್ ಮತ್ತೆ ಕಾನ್ವೆಕ್ಸ್ ಅನ್ನುವಂಥದ್ದನ್ನೇ ಯೂಸ್ ಮಾಡ್ತೀರಾ. Here also you are using concave and convex. Okay, so concave mirror, concave lens, convex mirror and convex lens. Then what is the difference between mirror and lenses? So ಏನ್ difference ಇದೆ ಅಲ್ಲಿ? Do you know what is the difference between mirror and lens? So here what I told, if you consider a plain mirror, ನಿಮ್ಗೆ ಒಂದು ಕನ್ನಡಿಯನ್ನ ಸಿಕ್ಕಿದೆ, ಒಂದು ಮಿರರ್ ಇದೆ. ಆ ಮಿರರ್ ಹೇಗಿದೆ, ಒನ್ ಪಾರ್ಟ್ is meant for reflection. Then second part, ಅದರ ಬ್ಯಾಕ್ ಸೈಡ್ ಒಂದು ಸರ್ಫೇಸ್ ಇದೆ, ಆ ಸರ್ಫೇಸ್ ಏನಾಗಿರುತ್ತೆ ಅದನ್ನ ನಾವು ಕೋಟ್ ಮಾಡಿರ್ತೀವಿ. ಎಸ್ ಆರ್ ನೋ? ಬಟ್ ಇನ್ ಕೇಸ್ ಆಫ್ ಲೆನ್ಸಸ್, ದೇರ್ ಬೋತ್ ದ ಸರ್ಫೇಸಸ್ ಆರ್ ಟ್ರಾನ್ಸ್ಪರೆಂಟ್. ಅಲ್ಲಿ ಯಾವುದೇ ಕೋಟಿಂಗ್ ಇರಲ್ಲ, ಬೋತ್ ದ ಸರ್ಫೇಸಸ್ ಆರ್ transparent. So that is the main difference between mirror and lenses. Okay, so in lenses, this is convex lens and this is concave lens. Okay, both the surfaces are meant for refraction. Okay, here reflection, here refraction. Okay, then another important point is, in this chapter, we are going to learn about the mirrors, about the lens, and what do you mean by reflection and what do you mean by refraction. And also we are going to study about the sign conventions for concave mirror, sign conventions for mirrors, and sign conventions for lenses. Okay, that is also very important. And power of a lens and magnification, right? So magnification in case of mirrors and magnification in case of lenses. So these all are the important points we are going to study in this chapter. So based on these concepts, we are going to solve some MCQ questions. Okay, shall we start? The focal length of a lens is plus 0.50 meter. The power of the lens and the type are. Okay, so power of lens means P is equal to 1 divided by F. That means reciprocal of the focal length, right? Focal length means what? See. Okay, focal length andre enu? This is a principal axis and the ray is coming parallel to the principal axis, and after refraction it will meet at a particular point. So when it meets that particular point, we call it as a principal focus, and the length between center and this focus is called focal length. So 1 upon F is the power of the lens. So here F is, focal length is 0.50. So P is equal to 1 divided by 50. So 1 divided by 50 is 2. So here negative sign is not there. So this is positive. So plus 2.0. D means diopter. So diopter is the SI unit of power, right? Power of a lens is diopter. SI unit of a power of lens is diopter. D means diopter. Okay, so which option is right here? Plus 2.0 D and convex lens, and plus 2.0 D and concave lens, and plus 2.0 D diopter and concave lens, and minus. So here minus is not there. So these two options are wrong. Okay. Next, convex and concave lens. So this is plus. So this is concave lens. Okay. Concave lens. Next, the nature and the size of the image formed when an object is kept between the principal focus F1 and optical center O of a convex lens are. Yes, whether it is virtual, erect and enlarged, real, inverted and small size, virtual, inverted and small size, real, inverted and enlarged. Yes. So which option is right here? Virtual, erect and enlarged. So here you can see image formation by a concave mirror for different positions of the object. Okay. When you place an object at infinity, then position of the image will be at the focus F. Okay, at the focus F. Size of the image is highly diminished, point size. Highly diminished means ಒಂಥರ ಚುಕ್ಕೆ ಥರ ಪಾಯಿಂಟ್ ಇರುತ್ತೆ, ಚುಕ್ಕೆ ಅಂತೀವಲ್ಲ. So highly diminished point size. Nature of the image is real and inverted. Okay, so when you place an object beyond C, beyond C means, so what do you mean by C? C means it is center of curvature. Elliratte center of curvature. Okay. See, when you consider a sphere, so center of the sphere, we call it as a center of curvature, right? So beyond C, ಈ C ಗಿಂತ ಹಿಂದೆ ಇಟ್ರೆ beyond C ಇದ್ದಾಗ position of the image will be between F and C. Okay, position of the image is between F and C, that is size of the image is diminished. Nature of the image is real and inverted. So this chart is very, very important. Okay. At C, when you kept object at C, then where you will get image? At point C only. And the image, size of the image will be same size as that of the object. The nature of the image is real and inverted. Beyond C and F, sorry, between C and F. So between C and F. Then position of the image is beyond C and size of the image is enlarged and nature of the image is real and inverted. At F, okay, at infinity, when you kept the object at F, then you will get image at infinity and it is highly enlarged. Tumba ದೊಡ್ಡದಾಗಿ ಕಾಣಿಸುತ್ತೆ, real and inverted. Between P and F, behind the mirror, enlarged, virtual and erect. So this is very, very, very important. Okay, these all are in case of concave mirror. Next we'll see nature, position and relative size of the image formed by a convex mirror. Okay, convex mirror. Position of the object at infinity. When you kept the object at infinity, then position of the image will be at the focus F. So this is very, very, very important. ಇದನ್ನ ನಿಮಗೆ MCQ questions ಅಲ್ಲಿ ಒಂದು question guarantee definite ಆಗಿ ಕೇಳ್ತಾರೆ. At the focus F, behind the mirror. Okay, behind the mirror. Mirror na ಹಿಂದೆ, behind the mirror. Size of the image will be highly diminished. Point size means just it is point size. Nature of the image is virtual and erect. Between infinity and the pole P of the mirror, then position of the image is between P and F. Between P and F, behind the mirror. It is also diminished. Diminished means adu kuda point size age kansutte. This is also virtual and erect. So in case of convex mirrors, nature of the image will be virtual and erect, remember. And size of the image is highly diminished and diminished. Next. One property of a convex lens among the following is that it diverges the light rays. It is thicker edges and thinner at the middle. So thicker at the edges and thinner at the middle. Forms real and erect image. It is thinner at the edges and thicker at the middle. Which option is right here? So convex lens ಕೊಟ್ಟಿದ್ದಾರೆ ನಮಗೆ, ಮಿರರ್ ಅಲ್ಲ, ಲೆನ್ಸ್ ಅಂತ ಕೊಟ್ಟಾಗ convex lens is like this. Yes, convex lens is like this. So ನಮಗೆ convex lens ಹೇಗೆ ಬರುತ್ತೆ? ಹೀಗೆ ಬರುತ್ತೆ. ಸೊ ಇದನ್ನ ನೋಡಿದ್ರೆ ನಿಮ್ಗೆ ಏನ್ ಅನ್ಸುತ್ತೆ? ಇಟ್ ಈಸ್ ಥಿನ್ ಅಟ್ ದ ಎಡ್ಜ್ ಅಂಡ್ ಥಿಕ್ ಅಟ್ ದ ಮಿಡಲ್. ಎಸ್ ಆರ್ ನೋ? ನಿಮ್ಗೆ ಎಡ್ಜ್ ಅಲ್ಲಿ ಇದು ಥಿನ್ ಆಗಿರುತ್ತೆ, ಬಟ್ ಮಿಡಲ್ ಅಲ್ಲಿ ಹೇಗಿರುತ್ತೆ? ಅದು ಥಿಕ್ ಆಗಿರುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ ಇಟ್ ಈಸ್ ಥಿನ್ನರ್ ಅಟ್ ದ ಎಡ್ಜಸ್ ಅಂಡ್ ಥಿಕ್ಕರ್ ಅಟ್ ದ middle. So this option is right. Okay. it diverges the light rays. No, it converges the light rays. So when in case of in case of convex lens, so concave mirror only it diverges the light. Therefore, it is called as diverging mirror there. But here, in case of convex lens, it converges the light, not diverges the light. It converges the light. Okay, so nimge light coming like this, and after refraction it will meet at a particular point. That means it converges the light. Okay, therefore option D is right here. It is thinner at the edges and thicker at the middle. Next one, list 4 characteristics of the images formed by plane mirrors. Okay, characteristics of the image formed by a plane mirror are: the image distance is same as that of the object distance. Okay, image distance is same as that of the object distance. Image formed is virtual and erect. Okay, virtual means what? The image is formed behind the scene, behind the screen, that we call it as a virtual. Erect means upright, straight ಆಗಿನೇ ಇರುತ್ತೆ. ನೀವು ಸ್ಟ್ರೇಟ್ ಆಗಿ ನಿಂತ್ಕೊಂಡ್ರೆ ನಿಮ್ಮ ಇಮೇಜ್ ಕೂಡ ಸ್ಟ್ರೇಟ್ ಆಗಿ ಇರುತ್ತೆ. ಅಥವಾ ನೀವೇನಾದ್ರೂ ಸ್ಟ್ರೇಟ್ ಆಗಿ ಇದ್ದಾಗ ನೀವು ಉಲ್ಟಾ ಕಾಣಿಸ್ತೀರಾ ಮಿರರ್ ಅಲ್ಲಿ? ಇಲ್ಲ ಅಲ್ವಾ? ನೀವು ಸ್ಟ್ರೇಟ್ ಆಗಿದ್ರೆ ಅಲ್ಲೂ ಕೂಡ ಸ್ಟ್ರೇಟ್ ಆಗಿ ಕಾಣುತ್ತೆ, ನೀವು ಉಲ್ಟಾ ಆಗಿ ನಿಂತ್ಕೊಂಡ್ರೆ ಅಲ್ಲೂ ಕೂಡ ಉಲ್ಟಾ ಆಗಿ ನಿಂತ್ಕೊಂಡುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ ಎರೆಕ್ಟ್. ಎರೆಕ್ಟ್ ಮೀನ್ಸ್ ಅಪ್ರೈಟ್. Image formed is of the same size as that of the object. Yes, image formed is laterally inverted. So this question can be asked for 2 marks. Okay, list 4 characteristics of the images formed by a plane mirror. Okay, so what do you mean by lateral inverted? Lateral inversion anta ಹೇಳ್ತಾರೆ. Left appears right and right appears left. ನೀವು ಎಡಗೈಯನ್ನ ಎತ್ತಿದ್ರೆ ಬಲಗೈ ಎತ್ತಿದ ಹಾಗೆ ಕಾಣುತ್ತೆ, ಬಲಗೈಯನ್ನ ಎತ್ತಿದ್ರೆ ಎಡಗೈ ಎತ್ತಿದ ಹಾಗೆ ಕಾಣುತ್ತೆ. That is called as lateral inversion. Okay, next. When an object is kept within the focus of a concave mirror, an enlarged image is formed behind the mirror. This image is real, inverted, virtual and inverted, virtual and erect. So this is virtual and erect. So option D is right. Why? Because when an object is placed between the principal focus and the pole of the concave mirror, an enlarged virtual and erect image is formed behind the mirror. Okay, behind the mirror. Next one. Draw a labeled ray diagram to show the path of the reflected ray corresponding to an incident ray of light parallel to the principal axis of a convex mirror. Mark the angle of incidence and angle of reflection. Okay, so here this is principal axis and this is a ray diagram for convex mirror. So this is a convex mirror and this part is coated. Okay, now the ray of light is parallel to the principal axis. So this is principal axis and the ray of light is coming parallel to the principal axis. When it reaches the convex mirror after reflection, what happens? It goes like this and it appears to meet at this point. ನಮ್ಗೆ ಏನ್ ಅನ್ಸುತ್ತೆ? ಈ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಮೀಟ್ ಆಗುತ್ತೆ ಅಂತ ಅನ್ಸುತ್ತೆ. Okay, so this is center of curvature C. Center of curvature means ಇದನ್ನ ನಾನು ಏನಾದರೂ full round ಮಾಡಿದ್ರೆ this is the center of the sphere, that is center of curvature, and here it meets at a particular point F. So here exactly they will not meet but it appears to meet. ಇಲ್ಲಿ exact ಆಗಿ ಒಂದೇ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಮೀಟ್ ಆಗಲ್ಲ, ಬಟ್ ನಮ್ಗೆ ಏನ್ ಅನ್ಸುತ್ತೆ? ಅದು ಮೀಟ್ ಆಗತ್ತೆ. Therefore we call it as appears to meet. Okay, so in case of convex mirror, the rays are appears to meet. Okay, but concave mirror ಅಲ್ಲಿ ಹೇಗಿರುತ್ತೆ? ಹೀಗಿರತ್ತಾ? ಸೊ ನಮ್ಗೆ ಇಲ್ಲಿ ಎಕ್ಸಾಕ್ಟ್ ಆಗಿ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ they will meet at a particular point and this is principal focus F. Okay, but in case of convex mirror ನಮ್ಗೆ ಏನಾಗುತ್ತೆ? So in case of convex mirror, This is a principal axis and the ray is coming parallel to the principal axis. So ನಮ್ಗೆ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ಇದು ಹೀಗೆ ಹೋಗುತ್ತೆ ಬಟ್ ನಮ್ಗೆ ಇದನ್ನ ನೀವೇನಾದ್ರೂ ಹಿಂದೆ ಅದನ್ನ ಡ್ರ್ಯಾಗ್ ಮಾಡಿದ್ರೆ ಇಟ್ ಮೀಟ್ಸ್ ಅಟ್ ದಿಸ್ ಪಾಯಿಂಟ್ ದಟ್ ಮೀನ್ಸ್ ಇಟ್ ಅಪಿಯರ್ಸ್ ಟು ಮೀಟ್ ಅಟ್ ದಿಸ್ ಪಾಯಿಂಟ್ ದಟ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಅ principal focus here. Okay, so this is F and this is C. Then what do you mean by pole P? Center of the reflecting surface. So center of the reflecting surface. So here it is a reflecting surface and center of this reflecting surface is P. That is pole. Okay. Then what do you mean by incident ray? So ಈಗ ನಿಮ್ ಲೈಟ್ ಹೇಗೆ ಬರ್ತಾ ಇದೆ, ಇಲ್ಲಿಂದ ಬರ್ತಾ ಇದೆ, ಇಲ್ಲಿಂದ ಬಂದು ಇಲ್ಲಿ ಟಚ್ ಆಯ್ತಾ. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ ಇನ್ಸಿಡೆಂಟ್ ರೇ. ಅಂಡ್ ಮತ್ತಿದೇನಾಯ್ತು, ವಾಪಸ್ ಹೋಯ್ತಾ. ಸೊ ಆಫ್ಟರ್ ರಿಫ್ಲೆಕ್ಷನ್ ಇಟ್ ಗೋಸ್ ಲೈಕ್ ದಿಸ್, ದಟ್ ಮೀನ್ಸ್ ದಿಸ್ ಈಸ್ ಅ ರಿಫ್ಲೆಕ್ಟೆಡ್ ರೇ. Okay, the coming ray is incident ray and going ray after going is reflected ray. So here when you draw a normal to this line, it makes two angles here. That means this is incident angle I and this is reflecting angle of reflection, that is R, angle of incidence and angle of reflection. It follows the rules of laws of reflection. That means angle of incidence is equal to angle of reflection. So I is equal to angle of reflection. R. Okay. So this is about the ray diagram. Ray diagrams are very, very important in this chapter. Okay. An object is placed at a distance of 30 centimeter in front of a convex mirror of focal length 15 centimeter. Write 4 characteristics of the image formed by the mirror. Okay. So ಏನ್ ಮಾಡಿದೀವಿ ಇಲ್ಲಿ, ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ಇದೆ. ಓಕೆ, ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ಇದೆ. ಆಬ್ಜೆಕ್ಟ್ ಇಸ್ ಪ್ಲೇಸ್ 30 ಸೆಂಟಿಮೀಟರ್ ಇನ್ ಫ್ರಂಟ್ ಆಫ್ ಎ ಕಾನ್ವೆಕ್ಸ್. ಇಲ್ಲಿದೆ ನಮ್ಮ ಆಬ್ಜೆಕ್ಟ್ 30 ಸೆಂಟಿಮೀಟರ್ in front of the convex mirror and focal length is 15 centimeter. Okay, the 4 characteristics of the image formed by the given convex mirrors are so when it is a convex mirror and the object is like this, the rays are coming like this. After reflection, what happens? The rays goes like this and the image is formed at this position. Therefore, image is always formed behind the mirror between poles and focus. Okay. What would be the angle of incidence for a light? What would be the angle of incidence for a light ray having 0 reflection angle? That is 0 degree. Because angle of incidence is equal to angle of reflection. Angle of incidence is 0, then angle of reflection is also 0. That means it is 0 degree. Full length of the image of a distance tall building can be seen using a convex mirror, a plane mirror, a concave mirror and none of the option. So ಒಂದು full tall building ಇದೆ, ಆ tall building ಅನ್ನ ನಾವು ಒಂದು ಸ್ಮಾಲ್ ಲೆನ್ಸ್, ಒಂದು ಸ್ಮಾಲ್ ಇದರಲ್ಲಿ ನೋಡ್ಬೋದು, ಮಿರರ್ ಅಲ್ಲಿ ನೋಡ್ಬೋದು. ಅಲ್ಲಿ which mirror you are using, whether it is a convex mirror or plane mirror, concave mirror or none of the above. Here you are using convex mirror, right? The ratio of the sine of the angle of incidence to the sine of angle of refraction is constant. Then it is given by sine of angle of incidence, sin I divided by sin R is equal to constant. So this law, it is given by Faraday's law, Snell's law, Newton's law or Murphy's law. Yes. So this law we call it as a Snell's law. Sin I divided by sin R is equal to constant. So this constant is called as refractive index. So that is Snell's law. Twinkling of stars. Twinkling of stars is due to which optical phenomena? Whether it is reflection, interference, refraction, divergence. So this is about the refraction. Okay. The laws of reflection are valid for convex mirror, a plane mirror, concave mirror, all mirrors irrespective of their shape. Yes. So which option is right here? All mirrors irrespective of their shape. Light from the sun falling on a convex lens will diverge at a. So ಇಲ್ಲಿ ಒಂದು sun ಇದೆ. ಇಲ್ಲಿ ನಿಮಗೆ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್ ಇದೆ. ಓಕೆ, ಸೊ ಇಲ್ಲಿ ಹೀಗೆ ಮಾಡೋಣ. ಸೊ ಹಿಯರ್ ಇಟ್ ಈಸ್ ಅ ಕಾನ್ವೆಕ್ಸ್ ಲೆನ್ಸ್. ಸೊ ನೀವು ಹೀಗೆ ಇಟ್ಕೊಂಡಿದ್ದೀರಾ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. The light rays are coming like this. Then after refraction, what will happen? The rays will converge. Okay, the rays will converge at a point. So that point we call it as a principal focus or focus. So convex lens will converge at focus. The magnification produced by a spherical mirror is -3. List 4 informations you obtain from this statement about the mirror or image. So this question was asked at 2016. Negative sign of magnification indicates the image is real and inverted. So this is important. Remember, real and inverted. Since the image is real and inverted and the mirror is concave mirror. So in case of convex mirror, it is positive, and in case of concave mirror, it is negative. Okay. So the mirror is concave and magnification is -3 indicates that the image is magnified. -3 indicates the negative sign indicates it is magnified. And when minus sign is there, then negative sign is there, then it is a concave mirror. Okay, remember. And image is real and inverted. Draw ray diagrams for the following cases when a ray of light passing through the center of curvature of a concave mirror is incident on it, and parallel to the principal axis is incident on a convex mirror, and the line is passing through the focus of a concave mirror incident on it. And this question was asked at 2020. Ray of light passing through the center of curvature of a concave mirror after reflection. So this is a concave mirror and this is a principal axis. So this is a convex mirror and this is a concave mirror. Okay. So here it is quoted. This is a principal axis. And now this is a center of curvature C, and this is pole P, and this is a principal axis. Now the light is passing through the center of the curvature. So remember, when the line is passing, when the light is passing through the center of curvature after reflection, it it passes in a straight line. Okay, so ಅದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮತ್ತೆ ಮುಂದೆ ಹೋಗುತ್ತೆ ಅದು. ಸೊ ಎಲ್ಲೂ ಕೂಡ ಬೆಂಡ್ ಆಗಲ್ಲ, ವಾಪಸ್ಸು ಬರಲ್ಲ. ಈ ತರ ಆಗುತ್ತೆ. Okay, so this is about the light passing through the center of curvature. A ray of light parallel to the principal axis is incident on a convex mirror. So here it is convex mirror. After reflection, appear to diverge from the principal focus of a convex mirror. So here it is a convex mirror. Okay, now the light is parallel to the principal axis. After reflection, what happened? The ray will reflect like this, but it appears to meet at this point. This is F and this is center of curvature C. Okay, and this is pole P. Now, if you draw one normal here, and this is angle of incidence I, and this is angle of reflection R. Okay, so this is for the ray diagram for light parallel to the principal axis is incident on a convex mirror. So here important thing is which mirror you are using. Okay, which mirror you are using, whether it is a converging mirror or diverging mirror. ನೀವು ಕಾನ್ವೆಕ್ಸ್ ಮಿರರ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಇಲ್ಲಿ ಡೈವರ್ಜಿಂಗ್ ಆಗತ್ತೆ ಅಲ್ವಾ. ಸೊ ಕಾನ್ಕೇವ್ ಅನ್ನ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಕನ್ವರ್ಜ್ ಆಗತ್ತೆ, ಅದ್ ನಮ್ಗೆ ಗೊತ್ತಿರ್ಬೇಕು. ಆಮೇಲೆ ಯಾವುದು ಪ್ರಿನ್ಸಿಪಲ್ ಫೋಕಸ್ ಆಗುತ್ತೆ, ವಿಚ್ ಇಸ್ ಪೋಲ್, ವಿಚ್ ಇಸ್ ಪ್ರಿನ್ಸಿಪಲ್ ಫೋಕಸ್, ಅಂಡ್ ವಿಚ್ ಇಸ್ center of curvature, that you should know. ray of light passing through the focus of a concave mirror after reflection will emerge parallel. Okay. So here ray of light passing through the principal focus. So here this is the center of curvature and this is a principal focus. So my dear students, this is a concave mirror. In case of concave mirror, light ಏನಾಗತ್ತೆ ಕನ್ವರ್ಜ್ ಆಗತ್ತೆ ಅಲ್ವಾ. ಸೊ ಬೇಸಿಕಲಿ ಏನಾಗತ್ತೆ ಇದು ಕನ್ವರ್ಜ್ ಆಗತ್ತೆ. ಸೊ ಈ ತರ ಹೋದ್ರೆ at this point it converges. ಇಲ್ಲಿ at this particular point two rays will meet. So that means this is a converging mirror. Okay. ಈಗ ನಮ್ಮ ಲೈಟ್ ಏನಾಗ್ತಿದೆ, ದ ಲೈಟ್ ಈಸ್ ಪಾಸಿಂಗ್ ಥ್ರೂ ದ ಫೋಕಸ್. ಸೊ ವೇರ್ ಇಸ್ ಫೋಕಸ್? ಫೋಕಸ್ ಇಸ್ ಹಿಯರ್. ಸೊ ದಿಸ್ ಇಸ್ ಅ ಪ್ರಿನ್ಸಿಪಲ್ ಫೋಕಸ್. ನೌ ಲೈಟ್ ಈಸ್ ಪಾಸಿಂಗ್ ಥ್ರೂ ದ ಪ್ರಿನ್ಸಿಪಲ್ ಫೋಕಸ್ ಆಫ್ಟರ್ ರಿಫ್ಲೆಕ್ಷನ್. ಇನ್ ವಿಚ್ ಡೈರೆಕ್ಷನ್ ಇಟ್ ಗೋಸ್? ಇಟ್ ಎಮರ್ಜಸ್ ಪ್ಯಾರಲಲ್. ಸೊ ಸಿ ಹಿಯರ್, ಇದು ಹೀಗೆ ಬಂದ್ರೆ ಈ ತರಾನೇ ಹೋಗುತ್ತೆ. ಓಕೆ. ಸೊ ಒಂದ್ ವೇಳೆ ಮೇಲೆ ಏನಾದ್ರೂ ಆಗಿದ್ರೆ ಅದು ಹೀಗೆ ಬರುತ್ತೆ. ಓಕೆ. ಸೊ ಪ್ರಿನ್ಸಿಪಲ್ ಫೋಕಸ್ ಥ್ರೂ ಹೋದ್ರೆ ಈ ತರಾನೇ ಹೋಗುತ್ತೆ. ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ದಿ ಲೈಟ್ ಪಾಸಿಂಗ್ ಥ್ರೂ ದ ಫೋಕಸ್ ಆಫ್ ಎ ಕಾನ್ಕೇವ್ ಮಿರರ್. ನೆಕ್ಸ್ಟ್, a concave mirror has a focal length of 20 centimeter. At what distance from the mirror should a 4 centimeter tall object be placed so that it forms an image at a distance of 30 centimeter from the mirror? Also calculate the size of the image formed. Okay. Yes. So here focal length is 20 centimeter. But it is a concave mirror. Which mirror it is? Concave mirror. In case of concave mirror, where image will form? So consider ಇಲ್ಲಿ ಒಂದು object ಇದೆ ಅಂತ ತಿಳ್ಕೊಳ್ಳಿ. Okay. So light is coming from the object like this. After reflection, where it goes? It goes like this. That means ನೀವು ಎಲ್ಲಿ ಇಮೇಜ್ ಸಿಗತ್ತೆ ನಿಮ್ಗೆ, ಈ ಪೊಸಿಷನ್ ಅಲ್ಲಿ ನಿಮ್ಗೆ ಇಮೇಜ್ ಸಿಗತ್ತೆ. ವೇರ್ ಆಬ್ಜೆಕ್ಟ್ ಈಸ್ ದೇರ್ ಅಟ್ ದಟ್ ಪ್ಲೇಸ್ ಮೀನ್ಸ್ ದಟ್ ಪೊಸಿಷನ್ ಆರ್ ಅಟ್ ದಟ್ ಡೈರೆಕ್ಷನ್ ಓನ್ಲಿ ಯು ವಿಲ್ ಗೆಟ್ ದ ಇಮೇಜ್, ರೈಟ್? ಇಲ್ಲಿನೇ ನಿಮ್ಗೆ ಇಮೇಜ್ ಸಿಗತ್ತೆ, ಇಲ್ಲಿ ಸಿಗಲ್ಲ ನಿಮ್ಗೆ ಇಮೇಜ್, ಇಲ್ಲಿನೇ ಸಿಗತ್ತೆ. ಎಸ್ ಆರ್ ನೋ? ಸೊ ಇನ್ ದಿಸ್ ಡೈರೆಕ್ಷನ್, ದಟ್ ಮೀನ್ಸ್ ಲೆಫ್ಟ್ ಸೈಡ್ ಆಫ್ ದ ಮಿರರ್ ಇಸ್ ನೆಗೆಟಿವ್. Okay, sign conventions alli nam baratte. Left side of the mirror we are taking, this is a negative and here it is a positive. Okay, when image is formed upward, then it is a positive. When image formed at the downward, then it is negative, right? So sign conventions alli baratte idu. If it is a concave mirror and image is forming on the same side as that of the object, then it is negative. Therefore focal length enagutte 20 centimeter. What is focal length? So where the rays will meet, at point only image will form. So here image is at point F. So at point F means it is a focal length. Focal length means the length between pole and the principal focus. So this is 20 centimeter, right? That is minus 20 centimeter. And V is 30. What is V? Image is at a distance of 30 centimeter. Okay, focal length is 30 centimeter and image ಎಷ್ಟಿದೆ ಅದು ಕೂಡ 30 centimeter. But image ಎಲ್ಲಿ form ಆಗುತ್ತೆ? Same side as that of the object. Therefore, it is also minus 30. Then calculate the size of the image form. But we don't know the object. Okay, distance from the object. Distance of the object we don't know. That is U is equal to question. So we know the formula 1 upon B plus 1 upon U is equal to 1 upon F. Yes or no? So now U we don't know. 1 upon F, transfer this 1 upon B to this side. Then 1 upon F is 1 divided by 20 minus 20 it is minus 1 divided by minus 30. Right? Now here minus 20 is there, here minus 30 is there. That means 60 is the LCM. Right? Here it is 3 into 3, 32 is 60 into. So 1 into 3, that is minus is there, minus 3, minus into minus plus 2. So minus 3 plus 2, that is minus 1 divided by 60. So this is 1 divided by u. Then what is u? 1 divided by u is minus 1 divided by 60. Then what is u? U is the distance of the object. So u is minus 60, reciprocal. ಹೌದಾ ಇದನ್ನ ಉಲ್ಟಾ ಮಾಡಿದ್ರೆ u ಸಿಗತ್ತೆ ನಿಮಗೆ. So that is minus 60. u is minus 60 centimeter. Then object placed at 60 centimeter from the mirror and find the magnification. Okay. So also calculate the size of the image form. Okay. Magnification. Size means ಎಷ್ಟು size ದೊಡ್ಡದಾಗಿದೆ ಅಂತಂದ್ರೆ that is magnification. So magnification m is equal to h dash divided by h. So object ಏನಾದ್ರೂ ಇಷ್ಟಿದ್ರೆ ಆಮೇಲೆ ಆಫ್ಟರ್ ರಿಫ್ಲೆಕ್ಷನ್ ಏನಾದ್ರೂ ನಿಮ್ಗೆ ಆಬ್ಜೆಕ್ಟ್ ಈ ತರ ಸಿಕ್ಕಿದ್ರೆ ಅಂದ್ರೆ ಇದಕ್ಕಿಂತ ಇದು ದೊಡ್ಡದಾಗಿ ಸಿಕ್ಕಿದ್ರೆ that we call it as a magnified. ಇದಕ್ಕಿಂತ ಆಬ್ಜೆಕ್ಟ್ ಕಿಂತ ಇಮೇಜ್ ಏನಾಗಿದೆ ದೊಡ್ಡದಾಗಿದೆ ಅಂತಂದ್ರೆ that is image is magnified. ಅದನ್ನ ನಾವು magnified ಅಂತ ಕರಿತೀವಿ. ಅದನ್ನ ಹೇಗೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತೀವಿ? The magnification can be find out by using h dash divided by h. That is height of the image divided by height of the object. ಈ height of the object ಇಷ್ಟಿದೆ, height of the image ಇಷ್ಟಿದೆ. ಇವೆರಡರ ರೇಷಿಯೋಸ್ ಏನಾದ್ರೂ ನೀವು ತೆಗೆದ್ರೆ then you can find out the magnification m. Okay. In other words, it is distance of the image divided by distance of the object. So minus v divided by u. Then minus v is minus 30 here. See here, v value is minus 30. Then divided by u is minus 60. So u value is minus 60. Now, at what distance from the mirror should be at a 4 centimeter tall object be placed so that it forms an image ಅಂತಂದ್ರೆ 3 ones are 3 twos are. So 0 0 will get cancelled. 3 ones are 3 twos are. So minus 1 by 2 into 2 is 2 ones are 2 twos are. So 4 times 4 centimeter tall ide anta kottidare. Therefore into 4. So 2 ones are 2 twos are. Here it is minus into minus plus divided by minus, that is minus. Minus 1 into 2 is minus 2 centimeter. Therefore size of the image is 2 centimeter. Minus 2 centimeter. Next one. An object 4 centimeter in height is placed at a 15 centimeter in front of a concave mirror. Okay, concave mirror of a focal length 10 centimeter. At what distance from the mirror should a screen be placed to obtain a sharp image of the object? Calculate the height of the image. So here also it is concave mirror. So concave mirror means image ಇಲ್ಲೇ ಫಾರ್ಮ್ ಆಗುತ್ತೆ ನಿಮಗೆ, ಆಬ್ಜೆಕ್ಟ್ ಇಲ್ಲೇ ಇರುತ್ತೆ. That means here also we should take image and object is negative and focal length is also negative, right? So object distance u is minus 15 because object is placed at a distance of 15 centimeter in front of a concave mirror. Here it is object. Adeshide 15 centimeter. So that is minus 15 centimeter. Object height. Object height they have given, that is 4 centimeter. And focal length, that is minus 10. So 10 is there. And the illi kuda concave mirror irodrinda focal length is minus 10 centimeter. Okay. Image distance v is equal to question mark. So image distance we don't, right? By using the formula 1 by u, v plus 1 by u is equal to 1 upon f. Again, we don't know 1 upon v, we don't know. So 1 upon v plus 1 divided by u value is minus 15 is equal to f is 1 divided by minus 10. So that is equal to 1 upon v. Transfer this 1 upon minus 15 to this side. Okay. When you transfer this minus 15, so plus into minus, it is minus 1 upon minus 15 to this side, then it is plus 1 by 15. So that means 1 by 15 minus 1 by 10. Yes. So this is minus. When you transfer this minus 1 by 15 to this side, then it is plus 1 by 15. So that can be written as 1 by 15 minus 1 by 10, right? Now, 15 and 10 is there. 1 by V is equal to 10 and 15. LCM of 10 and 15 is, so 10 and 15. 5 twos are, 5 threes are, then 2 ones are, 3 ones are, 5 twos are 10, 10 threes are 30, right? 10 threes are 30. 15 twos are into 2, 10 threes are into 3. So it is 2 minus 3, right? 2 minus 3 is minus 1 divided by 30. Therefore, 1 upon V is minus 1 divided by 30. Yes or no? V is equal to 1 by V is minus 1 divided by 30. Then what is V? V is equal to minus 30. Yes or no? In order to obtain a sharp image of the object on the screen should be placed at a distance of 30 centimeter in front of the mirror. Okay. Also, ಇಲ್ಲಿ ನಮಗೆ ಬಂತು V means it is a distance of the image. So when you want to get a sharp image of the object, then screen should be placed at a distance of 30 centimeter in front of the mirror. And also find the magnification. And magnification M is equal to H dash divided by H. That is minus V divided by U. So H dash, height of the image we don't. So here minus V divided by U. H dash we don't know, but H we know. That is height of the object they have given, that is 4, is equal to minus V value is minus 30 and U value is minus 15, right? Transfer this 4 to this side, minus 30 into 4, minus into minus plus, so divided by 15. 15 ones are, 15 twos are, so minus 2 into 4, that is minus 8 centimeter. Thus the height of the image is 8. Okay, height of the image is 8. Height of the image is 8 centimeter. Next one. What is meant by a power of a lens? Okay, so this question can be asked for 1 mark. The power of a lens is measure of the degree of convergence or divergence of a light rays falling on it. The power of a lens is defined as the reciprocal of its focal length in meters. So power of lens is equal to 1 upon focal length in meter. The SI unit of the power is diopter. It is denoted by the letter D. 1 diopter is the power of a lens whose focal length is 1 meter. 1 diopter means what? It is a power of a lens whose focal length is 1 meter. So what do you mean by power? It is the measure of the degree of convergence. ಎಷ್ಟು ಕನ್ವರ್ಜ್ ಆಗತ್ತೆ, ಎಷ್ಟು ಡೈವರ್ಜ್ ಆಗತ್ತೆ, ಅದರ ಡಿಗ್ರಿಯನ್ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? Power of a lens. Okay. So that can be defined as P is equal to 1 divided by F. F is the focal length here and focal length can be measured in meter. Therefore, it is 1 divided by focal length in meter. Okay. So SI unit is diopter. Remember. The diameter of the reflecting surface of a spherical mirror is called Diameter of the reflecting surface of a spherical mirror is called its center of curvature. R is equal to 2F, aperture or principal focus. So which option is right here? It is aperture. Remember, diameter of the reflecting surface is a aperture. The angle of incidence I and angle of incidence I and refraction R are equal in a transparent slab when the value of I is, when it is equal, when the incident ray falls normally on the glass slab, it will refracted without deviation. That is along the normal in the glass slab. That is I is equal to R. Angle of incidence is equal to angle of refraction. That is angle R is equal to 0. When it is 0 degree, then I is equal to R. So option A is right. A divergent lens will produce always real image. Divergent lens will produce always real image, always virtual image, both real and virtual image, none of this. So this is diverging lens will, diverging means here concave lenses. So in case of concave mirror, it is converging mirror, but in case of concave lens, it is diverging lens. Remember, will always forms a virtual, erect and diminished image. So in case of concave lens, or diverging lens, it produces virtual, erect and diminished image. Okay, next. A convex mirror is used for a rear view on an automobile has a radius of curvature of 3 meter. If a bus is located at 5 meter from this mirror, find the position, nature and size of the image. Okay, so here it is convex mirror. Okay, convex mirror. In case of convex mirror, where image will form? See, this is a convex mirror and the images appear to meet at this point. My object is here and image is here, right? Now, that means here this side is positive and here it is negative. Object, distance of the object is negative and distance of the image is positive. Okay, and radius of the curvature they have given, that is R is equal to 3 meter. Okay, object distance U is equal to -5 because object is at this side, so this is negative. Image distance that we don't know, V is equal to question mark. Then height of the image they have asked. Height of the image, that is H dash is question mark. So focal length F is equal to. So here radius R they have given. So focal length F is equal to, focal length can be determined as R is equal to 2F. Right? So R hegirutte 2F, 2 times that of focal length. Right? So F is equal to R divided by 2. So R value is 3 divided by 2, that is 1.50 meter, as the principal focus of the convex mirror is behind the mirror. Okay. Now, 1 by V plus 1 by U is equal to 1 by F. This is the formula. Okay. So here F they have not given directly. The R they have given. So by using this R, we can find out the value of F. 1 by V plus 1 by minus 5.00 is equal to 1 upon 1.50. Okay. Now, plus into minus minus, transfer this 1 divided by 500 to this side. That means 5 meter to this side. That is 1 by V is equal to 1 divided by 1.50 plus 1 divided by 5. Yes. So now 1.505. So LCM is 7.5. So 7.5 means here you need to multiply by 5 and here it is, actually it is 15. So 1.5 into 1.5. So 5, 1 into 5, 5.00, that is and plus 1.50. 5 plus 1.50 is 6.50 divided by 7.50. Okay, so this is the value of 1 by V. Then what is the value of V? V means reciprocal. So take reciprocal. 7.50 divided by 6.50. That is 1.15 meter. 1.15 meter. The image is 1.15 meter at the back of the mirror. Then magnification H dash is equal to, so image is at the back side of the mirror. So this is positive. Okay. Now magnification M is equal to H dash divided by H. So minus V divided by U. Minus V value is 1.15 divided by U value is minus 5. So 1.15 divided by minus 5, that is equal to minus will get cancelled, then 0.23 you will get, that is positive. So plus 0.23. The image is virtual, erect and smaller in size by the factor of 0.23. So image is virtual and erect. Erect means what? Upright. Okay, virtual means it is forming behind the screen, right? So yavaga behind the screen baratte, image is virtual. And ಇಲ್ಲಿ plus ಇದೆ. So plus 0.23 means it is upright. Upright means it is erect. Okay. So ನಿಮ್ಗೆ ಏನಾದರೂ ಉಲ್ಟಾ ಬಂದ್ರೆ, inverted ಅಂತ ಬಂದ್ರೆ, that is negative. But here it is erect, upright. Okay. So virtual, behind the screen you are getting. So that is virtual and erect, smaller in size by the factor of 0.23. So this is smaller in size. Okay. This question can be asked for 4 marks or 3 marks. Okay. Yes, have you taken? Shall we stop today's session and let us continue next problems in the tomorrow session? Okay. It's all the very best. Thank you. Thank you so much.